we were doing the account abstraction stuff, and I was supposed to demo that. Like, if you will watch my previous office hours recording, you will be able to get the context, but I don't really repeat myself. But basically, it's a way through which you can make the transaction on Ethereum without paying the gas. So for that, we will have to run a local chain, um, and this is a command to run that. And then later on, later on, we'll have to start deploying the contracts. So this is using hard hat, right? So I'll have to first install the dependencies, and when the dependencies will be installed, I'll have to run the compilation, and that's done in yarn preprocess. This repo is the implementation of the standard, which we call it as 4337. You can just read more about it. So it uses some external contracts. So when you run yarn preprocess, it's going to get those inside the submodules, and the contracts we need is what we call it as the account abstraction package. So that's what it's doing right now. It is installing the dependencies inside the submodule. So now lately it is now compiling all the contracts which are within submodules. It's called entry point contract. Okay, now we need to run the deployment. So this script is going to deploy the contract. We're getting some issue. Okay, this is basically my machine problem because I'm running this inside the container. I'll have to use instead of localhost, I'll have to use com.docker.internal for that. And I think we can do something here about it. Network dev does not access. Scripts as such. Wrapper. Okay, I'll give you a context of this. So I'll be sharing you the repository as well. Now the thing is, this is based on EAB 4337, and whenever any new standard is introduced, it will have its reference implementation. So the reference implementation for the same is available here. Okay. And so of course, I mean, I am having issues in my machine. Most probably, if you will be running in your machine, you should be able to have everything working. What I did is I had to make some changes to the configuration file for the local host. I had to like change it to host.docker.internal, just because I'm running it inside a container. But if you're not running inside a container, if you're running in your host machine, then this will just work fine, right? And the background for the same, you can find it from this guy. These are the smart contracts for that, and it represents implementation of EIP 4337. So this is what is something which I have actually covered in previous office hours. So the recording is already there. So I just don't want to repeat myself. So I'm just gonna go back here. And all right, so we're able to deploy the contract, and now we're gonna run the bundler. Okay, so when we are running the bundler, I'm just paying like more attention to each scripts, because I might have to make some changes, like the way that I did right now by changing localhost to host.docker.internal. I might have to do the same. So there's something that happens inside the bundler. Go here, just executes this called bundler.ts, and the configuration file is bundler.config.ts, which is here. Now they are using localhost again 8545, but I'm not having that, so I'll just go to this guy, go here, change it back to this point. So what's gonna happen is this guy called exe.ts. It will take the configuration from the bundler config, which I just edited, and this is going to spin up a bundler, and it will just run a server which is going to listen for any user operations, right? So let's do that. Now we are not working with the hard hat node, so I don't need to pass unsafe. Can just pass yarn run bundler, and we just assume that hopefully it's gonna work. So you can see that it is working on port 3000, and if you will be opening this in your browser, you should be able to see some message like the one which I'm saying. So if you're gonna do localhost 3000, this is what you're gonna use. Account abstraction bundler 0.7.0, right? And if I need to do anything, I'll have to ping RPC. Okay. So bundler is now available on this port. Next, what we need to do is we need to run the user ops. Now we'll have to test basically, right? I'm gonna go and I'm going to create a new terminal. So make sure we are running the blockchain. We are running the bundler. It's a server, and then we are now going to use this setup to test that we are able to make a transaction without requirement of the funds, right? So I'm just gonna go and just copy this network URL. What was Yeah, just gonna go. All right, here. So network is at again, like I'm running this in, you can see that I'm running my system in container. This is what my dev environment is. But if your dev environment is not in the container, just the host machine, and the instructions which are there here should work. Okay. So I'm gonna run this, and let's see what's happening here. So you can see that there is a user operation that got available. You can see some console logs being printed here. So these are all the calls that are made to the blockchain, as well as the bundler. So the script that we are running is not talking to the chain, but it is talking to the bundler, and then the bundler is the one that talks with the chain, right? So what happened here is, if you're going to take a look, we deployed the entry point contract at this address. Then this is the hard hat account that we got with that we funded. Okay. The funding can happen via the Coinbase account, right? Coinbase account is the miner account. We are running this blockchain in the mining mode, which you can see here. So it's in the mine mode. So it will have a default Coinbase account. Coinbase account is the one that we gonna fund it to the hard hat account, and that basically set up our entry point contract. Later on, we started the bundler. The bundler now will be able to receive the user ops. So the user operation came from the sender to this entry point contract. They are doing this contract as beneficiary instead of this contract, right? Then another user operation came from this guy. Then this particular entry point contract, and I think the rest isn't made. So let's see what's happening. So what happened here is it used this account index. Balance is zero, funding. So it funded the account. This guy did not had any balance, so it funded this amount. And then the required ID is this, which means the user operation will have its own ID. This is the transaction ID, and then it ran the first, and then it ran the another transaction, which you can see here. So two transactions, and then for the second transaction, this is the ID and this is the user operation request ID, right? So this is a simple test. So what it did, it deploys a wallet deployer, creates a random signer, then it determines wallet address, and it sends a transaction, and it is going to send another transaction on the same wallet. It uses account zero or mnemonic file for funding and creating the deployer if it is needed. If you are running on a testnet, you need to supply the bundler, the network, and mnemonic file. Or not, well, we are not using a testnet. We're using, we're using a local network, a private network, right? So basically what it did is you were able to, transfer the funds from one account to another account using the bundler, where, it facilitated that using the paymaster contract, and it was able to make transaction. So if you see this ETH underscore call, Saud ETH underscore call, Saud ETH underscore call, etc., it means that, it is making a transaction, right, from a signer wallet, basically. Okay. All right. Now, if you can find here, you can see that the execution got reverted. Okay, which is not what we intend to do, right? So that means there is something which is not running fine in the script. So let's see what is our entry, at what address the entry point contract got deployed when we ran this deployment script. So this is the address at which the entry point contract got deployed, DA032. Yeah, I think this is same. So run operation. Let's go to, so it uses packages bundler, run operation, src bundler exe.ts. Okay, so this calls this guy, and this calls oh sorry, src runner runup.ts, this guy. Okay, so yeah, this is the entry point. Let me see. Was it able to deploy the contract? Okay. This is fine. Bundler is also fine. Signer balance is 1. Connect to network. Chain ID running on this guy. Localhost 3000. Now I want to run the user operation. So go here. Bundler URL is localhost 3000, which is fine. Entry point nonce. Deploy the account deployer on this network. Yes. Sure. Okay, so what I feel is we're not displaying everything in the logs of the chain. Okay, so you can see that the moment I stop the chain, this bundler started giving issues. So what we'll have to do is we'll have to redeploy the contracts again. So I'm going to do that, and you can see that submitted contract creation at this hash from this guy, and this is where the contract got created, and one of the entry point contract is here. So if you do a control F, should be able to see contract. Okay, anyway, so submitted transaction, then submitted another transaction, this contract, submitted another transaction, and this is a recipient. Anyway, maybe sometimes, when you are making a transaction, it might internally deploy a contract and that might not show here, because it was deployed by a contract. There's a contract within a contract. So anyway, that might not show. But now we will be able to see a lot of logs here because the verbose level that I changed it to 3. Okay, so you'll be able to also see info level logs as well, right? So I'm going to run the bundler, and it's the same thing. So when I'm running the bundler, I'm just going to make some gap, so that we can figure out when we're running the user operation what it prints here. Should start printing something after here. So submitted a transaction with the hash, nonce is this is the recipient. Submitted another transaction. So to F, okay. Then it says that it made some transactions as well. But anyway, the thing is, I think the transaction is successful. I'm not sure about why this is executed. The execution is reverted because if would have been the case, then you know you should be able to see some errors here, but we are not able to see it. So yeah, so served ETH underscore call happened here, submitted the transaction. It also served it. This also submitted a transaction. Okay. Okay. So if you are still wondering, I think I should be giving you the background of that. What are we even doing? Okay. So what we did is we implemented a way so that we can make a transaction without having user to carry, gas. The theory goes like this. So when you are interacting with Ethereum, you are doing it using externally owned account. So externally owned account means the one which you have in your MetaMask is an example of an EOA. When you deploy, you get a smart contract account, and that's a contract account. That's what we call it. So you definitely need an EOA if you want to start a transaction or if you want to execute a contracts. But what if you don't have any gas? So that's a limitation. If you want to do some also, if you want to make some batches of transactions, like you are doing a payroll, and some employees would like to get token A, some employees would like to get token B, etc. If you want to batch them, then that's not possible as well. And on the top of that, if you want to make it without if you want to make it happen without any gas, then also it's not happening. So in order to solve this problem, we call this solution as an account abstraction. So there are several ways through which account abstraction can happen. One of the ways, you need to upgrade EOA, right? So upgrading EOA is another EIP, which we call it as 3074. Right now it's in the review state. You can see it's not recommended for general use or implementation because it might undergo any of the changes. This is reviewed so right now, but what it does is it allows externally owned account to delegate control to a contract, and they are introducing auth and auth call opcodes in that. Okay, that's one thing. So it requires changes to the protocol. Another way is you can create smart contracts, right? We call it as 2938. Okay, it will have a single tenant. What happens here is transaction. So you can split in single tenant A, which is intended to support wallets with their participants, and multi-tenant A, which is intended to support application with many participants. So Tornado, Cash, Uniswap, etc. Can be upgraded to support account abstraction as well. That's one way. Another way is, so this both options, as you can see, they will require changes to the protocol. So we'll have to go with some third path where we can have a second separate transaction system. So right now, what we demoed right now, what I demoed is we call it as the account abstraction using alt mempool, which is EIP 4337. So what is alt mempool? You saw that I was running the bundler. So that bundler is actually having an alt mempool. If I can show you the diagram of how this bundler software which I ran actually works, then I'll have to get to the Vitalik's article, which you can find it here. So just go to this guy, go to account abstraction. The link I have already shared it with you, and just look into the Vitalik's post. Right, this is an ultimate post which you should read. So this is what is happening. So if you can see here, let me take a pen. Okay. So when on the left hand side of the screen, I was running the blockchain. So that blockchain is this part. Okay. I'm running it privately, so it's not, talking to other peers, etc. Another part that I ran is the bundler. So this is the bundler. Okay. This particular part is a bundler. And then I ran a script, standalone script. So just treat it as a user. Now the users can do it manually as well, but I just did it as a script, which we call it as the run operations. So the run operation is going to add the user operation to the user operation mempool, which is the bundler. So this is bundler. This is user operation script, and this is what we call it as the blockchain, right? So these are the three components that we just did. So that's what it is, right? So if you'll read this article, Vitalik initially talked about it. Now you will find that when it talks to the blockchain has a smart contracts deployed. So this bundler account is the account which in I mean the account is of the bundler, and that account has the gas. Of course, I mean, practically you cannot make any transaction without the gas, but this bundler account is executing the transaction on your behalf by talking with the entry point contract. And these are all the architecture of the entry point contract. So your user operation goes here, it calls the handle ops method on the entry point contract, then it's going to check the wallet contract whether it can pay the gas or not. Then if it is able to verify that the gas can be paid, then it is going to then ask the wallet contract to pay the gas, right, to the bundler account, because bundler is bearing the gas for now. So once that verification is done, and once it is able to pay the gas, the next thing that will happen by the wallet contract is to execute the user operation. If you think that wallet contract paid excessive amount of gas, then after the operation of the user, this guy user have been executed, the wallet contract will get refund. Now your question will be, who is going to bear the gas, because bundler is paying the gas from their pocket, wallet contract is also paying the gas from their pocket. So whoever is funding this accounts should be incentivized. So what happens is, say for example, if your user operation is swapping token A and token B, and the contracts are built in a way that they can accept either the fees in either token A or token B. So what will happen is, when the user operation will get executed, the wallet contract will be receiving the fees in the form of token A or token B, whatever was allowed by the user, right? So that way you can do that. There's a very big opportunity, business opportunity here, where you can run a service so that other users can use your service to transfer any ERC20 token when you will be paying the gas. And what you can do is, you can buy ETH at a lower cost, and then after buying the ETH at lower cost, you can start the service, and price of the ETH goes up. What you're gonna do is, whatever is the market price of the ETH, you will be charging the user accordingly. And what will happen is, you will be able to make some profit out of it for the service that you are running. And at the same time, user can you know make a transaction without paying the gas as well, right? So it's also a good opportunity here. I mean, who are you the first one? No, this is actually being implemented by Circle. But the thing is, Circle is only limited to USDC. I mean, who Circle is? Circle is the merchant for USDC, the one who is responsible for minting the USD coins, right? So this is a very brief introduction, like very non-technical introduction. And what we did today is, we looked into EIP 4337. Now there is also another implementation as well, which we call it as 2771. Now, when you will be going through our modules, we have included 2771 as well. We call it as meta transactions, gasless transactions. If you were part of the orientation meeting, I might have been talking about it a lot. So yeah, you'll be learning about it. Now, why not 2938 and 3074? Now this is making change to, protocol. These are all the protocol level changes. Until now, these changes have not yet taken place, which we saw, right? But it is always beneficial to stay in touch for DIPs. Now, as I have got a chance right now about this is where you will be able to find all the alpha knowledge about what is the future of Ethereum, what is the present situation of Ethereum, what will happen in future and all those stuff. So Ethereum improvement proposals are there. It's a purely democratic way to get whatever your idea or whatever upgrade you want to champion in. So it could be you as well. After you graduate, there might be issues that you might have found with Ethereum and you want to make some, proposal. So you can be one of them as well. It's very simple. All you need to do is just go to GitHub Ethereum EIP repository here, and whatever what do you call, whatever changes that you would like to see in Ethereum, you can do it by creating the issue. So if we talk about ERC20, the ERC20 was actually uh, you know created as a result of somebody creating an issue of that, right? So if you can just see here, ERC token standard. So this was first, this is the history of ERC20. It started here by creating an issue in EIP. To create any other standard, you can also create an issue here. So it was Roseman, and then he's not the only one. Actually, right now this guy Fabian Vogelsteller is running Luxo. Luxo is a blockchain. So this function, this ERC20 was proposed by Vitalik and Fabian Vogelsteller, which you can see here. Now, this is hosted on a different page, but initially it started here where they created an issue with all the specification, and there was a full discussion that happened on Reddit. There was an initial post by Vitalik. Then they are, also referencing any discussions that happened with respect to ERC20. So right now, the ERC20 which you are using did not just as is. There was a very high level and a very broad discussion that happened. And if you want to, introduce your own standard, or if you want to propose your own standard, you'll also have to do similar things. You'll have to discuss with the community. So this was one of the older way to do it by by making the user participate in issues by commenting. But right now there are very good tools which you can do that. The tools which are right now for discussion, what for discussing EIP is we call it as Ethereum Research Discourse Forum. So it is this guy. I'm going to share the link with you so you can get the discussion and get the community inputs here. So you will get all the dissenting, consenting opinions. And another which I know is Ethereum Editions. There is another discourse forum where also you can create discussion groups and get your proposal consented dissented. Right, so there is a whole lot of process that happens in order to get your proposal enacted. So for that, there is a whole constitution for the same, and that is known as EIP1. So EIP1 has everything that you need to know on what is the administrative procedure for getting your proposal accepted. So this is the process. It's a pretty theoretical thing, but once you read it, you will get to know, which I'm sending you here as well. Now the thing is, I have posted a lot of links. Just don't keep it here. Just bookmark it, and then after we are done with the call, just over it. Whenever you are free, read it, understand it. You don't have to remember anything. Just keep on reading and understand. Right. So that's pretty much about it. Now the demo that I did, if you want to do it yourself, I have posted the link with the repository named Bundler. So you can just follow the README by your own as well, and you'll be able to run in your own machine. Right. So before we end this discussion, do you have any questions?
In which module we will touch these topics? Like at the moment, for me, it's
Yeah, 1 to 0 5 6.
many abstract.
I think it's in module 12, I guess.
Okay, great. So we will have sometimes to gain the knowledge to understand.
Yeah, basically, right now, one thing that you should be convinced that if you want to make any transaction, you need to pay gas for it. Right? Are you
Okay.
convinced with that fact?
Yeah, yeah, okay.
Yeah. So if you are convinced with that, then it is a problem as well. What if some user would like to do a transaction without the gas? Right? You have the ERC20 token. You received it in the form of airdrop. Now you want to use it, but you don't have gas. So that is where account abstraction comes in. And another use case would be you want to make transactions in batch. Like I have to do make some transaction. You want to make some transaction, but I want to batch it up, like mine and yours. Doesn't matter. We both know each other or not. So how to solve that problem? So it's an account abstraction. Do that.
Okay.
So
Yeah.
yeah. Yeah, so it's all trustless way to do it. You don't have to trust, like if you want to batch your transaction and my transaction either in the same block, like you don't really need to know who am I. Just you have to sign the user operations, the intent that you want to do, and then just post it to the alt mempool, which is powered by Bundler, and yeah, it will just work by the Bundler's account.
Okay. So the bundler account pays the gas for you and me.
Uh, Technically, canonically, it will be bundler account, but there will be a paymaster contract which is going to compensate the bundler account.
Okay.
Paymaster contract is the one which is going to pay, but technically, of course, any transaction needs to happen via gas. So somebody will have to initiate it. So that initiation is done by bundler, but they will be getting all the gas cost compensated from the paymaster contract. And that is a part of the bunch of smart contracts that we have deployed initially.
Okay.
Hmm. You saw that we are using something called entry point contract.
Yeah. Okay.
Yeah. So that's that. There's a sub module that we downloaded, and that sub module is having all the smart contracts, including the entry point contract. So you can also read that for repo as well. It's a hard hat project.
Okay. Thank you.
But guys, let me know if you need anything. Till then, let's do something next office hours as well. Bye for now.
Bye. Bye. Bye.